Hello everyone, welcome back. So in this video we are going to understand a LeetCode 1039 problem where we have to find the minimum score triangulation of polygon. Okay, so today we will dive in very deep and we'll try to understand, because this is a classical dynamic programming problem that's very similar to the matrix chain multiplication, right? But we will wrap into we have to wrap into polygon settings, we can say that, right? So in this video we will try to break down the problem into very simple steps, and we'll walk through the examples, right? I'll try to cover the DP in the very simple steps, we can say, and we'll build the intuition of this given problem. Okay, and definitely we'll go with the Java programming, so we'll implement it into Java, and finally we'll discuss the other approach, why the DP is the best here, why the DP fits here best. So we'll discuss about that. Okay, so let's try to understand. Very first, the question is saying that you have given convex is a polygon, okay, where n-sided polygon it is saying, okay, means there is the sides are not given here, sides are given, but it is saying n-sided polygon. Okay, so it is saying n-sided polygon, as you can see we have given here. So you have to assume that these are the sizes, we can say that, and we can say if you calculate all of them from the array, we can say this is the n-sided. Okay, so for each vertex has an integer value, and you are given an integer array that is called values, where values at I is the value of ith vertex in clockwise order. Okay, so the polygon triangulation is a process where you divide a polygon into set of triangles and the vertices of each triangle, and must also be possible of the original polygon. So we have to note that no other shape other than the triangles are allowed in the division. So this process will result into n-1 triangle. So you will triangulate the polygon first. Okay, so for each triangle, the weight of that triangle is the product of the value of its vertices. So the total score, we can say, of the triangulation is the sum of the weight of all the polygon over all n-1 triangles, right? It will come n-2 triangles, we can say, that will come. So we have to return the minimum possible score that you can achieve with the sum triangulation of this polygon. Okay, so we should always read the question one or two times. We should read and then we can understand, right? So very first it is saying that we have what? We have n-sided polygon, right? Means we can say we are given a convex polygon, right, with n vertices, we can say that. Okay, how many vertices? N vertices. So each vertices has a integer value, correct? When we triangulate the polygon, meaning we cut into how many we will cut into n-2 triangles, right? The polygon that we have given, we have to cut into n-2 triangles, we can say, right? So for each triangle has a score which is equal to what? Equal to the product of its three corner, right? So that product we have to take the product of the values of its vertices, we can say, or we can say its score is equal to what? The product of values of its three corner. Vertices means nothing but the corner, we can also say that. Okay, so the total triangulation score is the sum of all the triangle score, right? If you want to find the total score of the triangulation, is nothing but what? Is the sum of all the triangle scores, we can say, right? So that we have to return, right? This is not that we have to return, we have to return the minimum possible score. Okay, our job is to find the minimum possible score over all the triangulation, right? But the total score of triangulation is the sum of their weight over all the n-1 triangles, meaning sum of all the triangles score, we can say that. Okay, I hope you understand. Let's understand this example. Let's think that the example we have given is very simple. Example 1. Okay, So example one, we had given the, let's suppose the values, right? And it is saying 1, 2, 3. Okay, this is what we have given in a array, we can say this is our values, correct? So this is already a triangle, right? If we'll take the, because there are only 3 sides, we can say, so it's already a triangle. Triangle needs 3 sides. If this is 1, this is 2, this is 3, just for understanding. Okay, so there is only one score, we can say. How we can find the score? So we'll say, okay, the score we can get is 1 into 2 into 3, and it will come what, 6. It will come 6, right? And this is our answer, and it is coming, correct? So for this is very simple. Let's talk about example 2, right? So we have example 2 where, let's suppose the values we have given is in an array. One more value we will take here. Okay, let's call 3, 7, 4 and 5. This is what we have given. Now think about this. Think about that. This is a quadrilateral, because we have how many size we have? 1, 2, 3, 4. So if we'll take a array, or you can say a polygon, or we can say that if having 4 sides, 4 sides we can say, or 4 vertices we can say, this is nothing but a, it's called, because it's a 4 means quadrilateral, right? Quadrilateral we say, right? Quadrilateral, yeah, we will say quadrilateral with 4 sides we use say, or 4 vertices you say, because how many sides we have. So if you find the values dot n, we can get the n, right? And if n is 4, means this is quadrilateral, right? If it is 5, we can say it's pentagon, not pentagon type we can say, or pentagon we can say that, right? So we'll say, okay, then if 6 hexa we can say 7, like that we can say, we can get the n, and we can assume that this is our polygon, we can say. Okay, so if we draw if we can draw these different polygons, right? Let's suppose we have, very first is a diagonal we will have, where we'll say, okay, we have 3, 7, this, right? So let's call a diagonal, let's call from 0 to 2 we will take. Okay, so can we say this is 0, this is 2? So if I'll take one angle here, okay, we'll say, okay, we'll take one here, let's suppose. So we'll say this is our 1, right? If I'll take here, let's call 3 here, right? So there will be a chance that we can make a triangle here, right? And if I will assume 0, 2 and 3, we can create one triangle here. Can we say that? We can say that, right? And this we can mark it, mark like this one also. Okay, so this type of become what? A polygon, where we can get true triangles, right? So we'll say, okay, let's find the score, right? So we'll say 0, 1, 2, 3. Okay, so this we will take as a quadrilateral. In this, if we want to find the score, let's call, we'll take the very first 3 and then these 3, we can say that. Okay, so if you want to find the score, let's call this 3 into 7 into 4, and this will give you what, 21 into 4, 21 into 4, right? So it will come 4, it will come 8, it will come 84, right? Then we have, let's suppose we'll say 3, we'll take 4 and 5. Okay, we'll take this one, and will not take this time, this one will take this, and this time we will take this and this. Okay, we can say very first element will take. Okay, in that case the score will come what? The score will come is 12 into 5 is 60. Yeah, now check the total score. You will just do plus this, and this will be added, right? It will come 4 and 8 and 4 is 4. Okay, 114 it will come, correct? So this is the score if we'll take like this. Let's suppose if you draw a diagonal that will take 1 and 3 first. Okay, so it's all depends on you how you are drawing that, right? Let's call the 1 and 2 is already there, right? We have took what 4 and 5. Okay, and for that the triangle is 1 3, and we'll take 1 2 here. Let's call, so we'll form like this. Okay, if I'll take 1 0 is also there, right, like this. Okay, so we'll say, okay, one triangle will make like this, another triangle is what, we'll say 1 0 and 3, you can say that, and this will be keep adding as a thing. So one triangle is that we can form like this, right? Another is like this. So it's all depends on us how we are creating and where we are putting the things, right? So possibility is that you take the diagonal either 0 to 1 3 or 1 to 1 0 like that, and you find the triangle. So possibility is that you will get the triangle like this, right? So in this case also, let's suppose we have two triangles. We have 1 2 3 one triangle, and another triangle we take 1 3 0 the triangle. If you'll find the score here, we'll say 7 into 4 into 5, for example, it will come approximately 140. If you multiply 7 5 into 3, we'll get 105. So the total will get what is 245, we can say that. This is what we will get. So what is the minimum will come? Let's suppose it was coming 144, but this was coming what, 245. So this is our minimum. So we'll say this is our minimum score is coming. So we'll use this one. Okay, so there is many possibilities, means you can find, I'm trying to say just that we have many possibilities that you can find the maximum score, right? So for forming a, for the given values of the polygon, the quadrilateral can be you can use this one or any other else. So if you're using diagonal this one, you can change this diagonal, right? Like previously, let's suppose, for example, let's understand here. Let's suppose I'll go with a triangle here where I will use one diagonal 0 here and another is 2 here, right? We know that this is 0, this is 2, so we'll say okay, then 3 will come here, and we'll say okay, 4 will go here, and we say that. So if we'll draw 0, no sorry, this will become 1. Okay, yeah. So if we will take this diagonal like this is the possibility that we can form like this. So there is first way that we can form the polygon here. Let's talk another one. If we'll take another one diagonal where we'll say okay, this time I'm supposing this is our 1 and this is our 3. Okay, so this will be our main diagonal. Okay, so this 0 and 2 will remain the same, right? So it's all depends on us that we are using this diagonal or this diagonal, because if we are not forming this diagonal, right, I should not write this one actually like this, right? So how many triangles is there, right? If you are using only this one, how many triangles are there, right? So two triangles are coming, okay, in each cases, right? Either you will use this one or you will use this one. So when you are using this one, what is the score is coming? Let's suppose we have used the triangle, let's suppose is 0 1 and 2. One triangle we found here, right? In another case we found this is our one triangle, and this is our another triangle. So here we got 84 as a score, here we got 60 as a score, remember? So we added this and we found that the score came here is nothing but is 144 score. Okay, in the case of this one where we use the diagonal this one 1 3, in this case we'll say okay, what we got here. So triangle was, we assume that the 1 2 and 3, so we taken one triangle like this, right? And another is this. If this is our one triangle, this is our another triangle. So in one triangle if we are assuming 1, 2 and 3, right, here we got 140, let's suppose the score, and here we got is 105 score. If both we have added, we got the score is what, 245, right? So as you know that we got for n equal to 4 vertices, right, and this is our what, quadrilateral, we can say quadrilateral, yeah, okay. Quadrilateral we have formed where we have the two possibility, either you will make this possibility or these possibilities, right? If you assume the diagonal is this, and if you assume this diagonal is this, so if you are assuming the diagonals, you are getting the two different score, right? But we need to find the minimum one, so we'll say, okay, I will assume this one, and we need the minimum one, so I will assume that diagonal 0 and 2 will work for us, and this is our minimum score. This is the question is saying that, okay, right? So now the problem is that if let's talk about the if we will transition into DP, okay. Let's talk about the transition into a DP, or in DP we can say, okay. Very first we should understand how do we solve this systematically. So whenever we draw a diagonal, we have seen, right, that either you are using this diagonal or this diagonal, right? So whenever we draw a diagonal, let's call 0 and 2, right? So I will talk if we are going for the diagonal, not 0, 2 will say, in this case we'll say I and j, okay. So whenever we draw the diagonal, let's call I and j, we split the polygon into two smaller polygons, right? You have seen we have, if we take the diagonal 0, 2, we have splitted 1 and 2, then we have splitted here also like this. So whenever we draw, there is possibility that we will split it, right? What we will do, we'll say a split into two smaller polygon, right? What is the smaller polygon? As you can see here, this was quadrilateral, means 4, right? So when we split this with this diagonal, right, if we split with this diagonal, we'll get how many? We'll get two part, the first part and the second part, right? So this will become from 4, it will become what, 3, 0, 1, 2, because we have splitted that. If we have splitted that, right, it means we have converted into a smaller polygon. Now the polygon of size is what, is 3, right? 0, 1, 2, and another we have is 0, 3, 2, and similar for this case also, right? Means, can I say that what is the transition into DP? Because if we make a diagonal, if we draw a diagonal, right, we have to split this polygon of size, let's suppose, for example, for us is quadrilateral, and into two smaller polygon, that is for two triangles, right? Can we say that? Understanding, right? I hope you are understanding. If you have any doubt, guys, you can ask me in the comment box. So let's say from how we have taken the diagonal, let's call, we'll say I to k, there is a possibility, and there is another possibility is that you can take from k to j, right? If you see, we have taken 0 to 2 is one diagonal, we have split it. Another we have taken is 1 to 3. Can we say that? This is why I'm saying I to k and k to j, right? So now I can say, okay, find the cost. So okay, I'll say cost is what? If I have something called dp at I and dp at j, means we have to what? We have to check that the score is 144 and 245, right? But in this case, what we need? we need a minimum, right? Both you see minimum is 144, right? So we'll say minimum over k, and then we'll say okay, what is the dp at I and k, correct, plus dp at k and j, right? If you see here, the one I've taken 84 and 2 is 60. So this part will give you dp at I, k and dp at kj, it will give you, right? This is the very first part that we have taken is I to k, and it gives you here. Okay, now after that you will do the plus. Okay, after here you will do plus. Now we'll talk about the another case, this one where we have changed the diagonal 1 to 3. Another, we also getting 1 and 2, two triangles we are getting, and we are getting the score 245, right? So that part we have to also take. So in this case we'll say okay, means dp at, we'll say, or we can also say not to dp at this, but you can also take like this. You will say okay, if you know the values at I into values at k into values at what, j, you can multiply it, because 3 values we need, right? So this will give the minimum, because we are iterating over here, and we will also taking the j. So if dp at I we can get directly here, right, and dp at j will take from here, right? So we can take in both places and we will multiply with this, right? So we can do that, okay, because we are iterating over again, right? So we'll use this one. So now we'll say okay, this is nothing but our dp recurrence value, right? Give me 1 second. This is called let's call interval dp recurrence. Okay, dp recurrence value, we can say that, okay, and we will get it. Let's try to understand how this works, right? Very first, I'll say let's actually build a dp table for the quadrilaterals. Okay, so let's build dp table for, we can say, quadrilateral was 3, 7, 4 and 5. Okay, this is the things we have given. Let's build it first. So we will define, let's call dp at I and dp at j, and this is nothing but it will give you what, the mean of triangulation cost from vertex I to vertex j. Can we see that? We can say that, right? Now let's say call the base case, and base case is what, if we'll say j minus I is less than 2. If j minus I is less than 2 means no triangle possible, right? Can we say that? In that case we'll say okay, dp at I and j starts with 0. This is our base case. Okay, now fill for length 2. How? We'll say okay, dp at 0 and dp at 2 is what, we have taken 3, 4, 7, 5, right? This we have taken So we'll say, okay, dp at 0 and 2 is nothing but 3 into 7 into 4, right? 21, and into 4 is 84 we got, right? Similarly, we'll say, okay, dp at 1 and dp at 3 we can get is what? It will come 7 into 4 into 5. So 728, okay, 5 into 140, right? It will come 140. Now we'll say, okay, now the length is what? 3. So we'll say, okay, dp at 0 and 3 we can get what? Minimum of, right? What is the mean of? Mean of, we'll say k when k equal to 1, right? In that case we have to find what? dp at 0 and dp at 1 plus dp at 1 and 3, and here we will do what? 3 into 7 into 5, right? Similarly, we'll do k when we have equal to 2, we'll take what? dp at 0, then dp at 3, dp at 0 and 1, then we'll take, no, we should take dp at 0, 2 we can take, right? And then we'll say, okay, for this case we'll say, okay, dp at 2, and this will become dp at 3, 0 1 and 0 2, yes. Then we'll say, okay, multiply 3 into 4 into 5. So we know that we have to find this minimum, and this is exactly, we have 245 and 144, correct? And out of this, what the mean we have to take? We have to take the mean that we have found. So we'll say mean is coming 144. Okay, means dp at 0 3 is nothing but 44 is a minimum. This is what we need to implement. So what we need to do, we have to implement this, right? Very first, what we have done, see, we have taken the dp ij, we have taken the base case, and then we have to fill the values, right? And then we have to calculate the value. Means, let's suppose we have given a function contains the integer and it gives you the values, right? It gives you the values, right? So you will get some values, you can say, in the array form, correct? Let's, if you find the n is nothing but what? We can say, okay, values dot length. What you have? Values dot length. You will find the values dot length, right? Then you will create int dp, and you will say, okay, this dp should be 2d array. So we will define the 2d array like this, okay? And you will say, okay, the new, and you will say int array, and you will pass 2 times n into n, right? This is our dp table. Now we will say, okay, make a for loop that the length should start from where? 2. It should go to length should less than n, and length plus we will say, okay. Here we have to take a for loop for I will start from 0, and will go I should be plus the length, and it should be less than n, right? And then I plus plus. You understand, right? We will take the length, we have to divide into 2, right? When we split this, so we have to split into 2. So we'll, after the split, we have to calculate the dpr. For that we have to start for the I, right? Like that. So we'll say, okay, you will get the j. You don't need to find the j. You will say, okay, I plus length. You will find the j, correct? Then you will calculate here dp at, let's suppose, I and j, and you will say, let's take the infinity, max infinity value. We will take the positive infinity value, we will take, right? And then you will start the for k, right? After that, let's think that you will take a for loop, and you will say int k, and you will say, okay, start with I plus 1 and go k less than what, j, and k plus plus. Okay, after this you will say, okay, first of all I will find the cost. How will find the cost? We have seen that we will use dp at I and k and dp at k and j, right? Then the values at I into values at j into values at k, I, j and k. Okay, we will take, so you will multiply all of this, right? You will find the cost. Now you have to find the mean, so we'll say, okay, dp at I and j is nothing but the mean of what, math.mean. You can take the math.mean and we'll say, okay, dp at I and j and other you will use a cost, means you are tracking the dpij, okay, for all the for loop. Okay, once this for loop is completed, all these things done, you just need to return what, dp at 0 and n minus 1. That's all, right? And in this way, if you see, we have taken one for loop here, another for loop here, right? And in between we have taken another for loop is this here. So we'll say for the time complexity it will come O of nq, right, time, and for the space complexity it will take O of n square to store the value dp. Okay, because dp takes n into n it is taking, right? So it will take of n square, and this is fine. Okay, let's go to the console and try to understand. But before that, let me recap, right? It's easy. So very first, we know that for the minimum, if there is only one triangle is there, so you cannot divide the triangle, right? Because this is our base case. If you divide this triangle, that is not possible, right? So we need at least one to make the diagonal to convert it, right? So very first, if the smallest triangle is there, you just multiply all of them and you return the answer. Otherwise, if you have a quadrilateral, right, means we can make a diagonal, we have to split into two with the two smaller polygon, right, as we have seen here and here. After that, you will find the score and you will take the minimum score, because we need the minimum score. So if you talk about the transition into dp, you need to do what? You have to find the diagonal. Let's call the diagonal of polygon you will take, means you have to split that diagonal, you have to split the polygon into two smaller polygon, like we have seen here. The big polygon we have converted into a smaller one. And how we will go for the diagonals, I to k and k to j, like we have gone for 0 to 2 and 1 to 3, right, in both cases, right? We have gone 0 to 2 and 1 to 3. Okay, then these two possible diagonals will find the minimum over the minimum score. So we will, to find the minimum score, you have to track this dpi and j, where you will go for all the k, right, you can say, and you will find the minimum over this, right? And this is nothing but our dp recurrence relation, where you will multiply all of this. Okay, now let's talk about building the dp. To build the dp, you have to create a dp I and j, right, and it will store the minimum cost, right? And this is a base case. So base case, if the j minus I is less than 2, means there is no triangle forms, right, and we'll define it as 0. To fill the length 2, let's call length is 2 only, right? In that case, means we have the triangle, we will make the two triangles there, so we will get the sizes, and we know the sizes. After that, you need to do what? Minimum you have to roll over. Once you do the minimum over there, you will find the scores and you will return the minimum score. And for the writing the code, you know that you have given the values in the argument, you just need to do what, that you need to find the n. You will create the dp table like this, and then for all the length, because we know that we have to split into 2, so we'll split into 2, and we'll say okay, let's go with the I and j. So we'll go with the I and j, and you will find the k, right, and you will find the cost, and once you iterate over the k, you can find the minimum cost here, and finally you will return the minimum cost. And if you talk about the complexity, we'll take of nq and of n square. Okay, let's go to the console of the LeetCode and we'll understand the code. So this is what we have done. We know that the argument will be values. So very first find the n, then you create the dp, right, and we know that the length from 2 triangle is n-1 is polygon, right? So we'll take the length, right, and you will go for all the I and j, right, and you will calculate the dp, right. You will take the dp at I and j, so we'll define the positive integer max value, and then you have to take the minimum you have to update, so you have to take the max value, and then you will choose the middle vertex where we will find the diagonal, and you will find the minimum dp cost. You will find, you will iterate over this and you will find the dp, or you can take the math.min also, or you can track this like this. Okay, and then similarly, if it is max value, you apply the value at the 0, right, and finally do the dp at 0 and -1, you will return. It will work. Okay guys, so it's working fine. If you submit this will work. Yeah, it's working. So that's all I have today, and thank you for watching this video. In case if you need any help, let me know in the comment section. And for any systematic classes, if you're doing the preparation for FANG or any product based companies, and if you want to prepare the systematic way where you will have a clear understanding of how the plan is, and there will be classes where we have the first month we will go with understanding the basics Java questions, or even whatever the language you're using. Then we'll go for the some interview questions. Let's suppose you are Java developers, or you are preparing with the Java. You will start with the Java with the interview questions the first week, and the second week you will start with the topic wise brush up, like algo, DSA, these things, and then from the 1 month onwards you will prepare for the interview perspectives, and the next after this month you will go for the system design, right? For the very first month you will understand the array, stack, linked list, queue, and the next month you will start with the tree, graph, dynamic programming, recursions, and then you will prepare in the systematic way. So there is a very good approach to understand and crack the interview. So let me know in the comment section. You can reach out to me on the WhatsApp, and you can have a daily session. This will be a 6 days classes, and I'm going to start a new batch. So ping me in the comment box if you need. Thank you guys. Thank you for watching this video. I'll see you in the next one.